Welcome to Codology, NEC Bits. What is the violation in this photo? This installation met all the code requirements for the clearances and the nail guard protection. However, when the foam seal was added to stop the path of fire from the one floor to another, a new violation was created. As we go through this course, I will explain to you why this is a violation of the electric code and how to account for it. In our photo, we have non-metallic cable, often referred to as Romex. Each cable has a hot and a neutral, along with a grounding conductor. Hot and neutral wires are considered by the code as current-carrying conductors. They are not normally placed in pipes, so the heat dissipates to the surrounding space and thus remains cool. One thing we know about electricity is that it generates heat. Two things that we know about plastic is a great insulator and it melts. This is a model of how the cables would work without the foam. They're passing through a wood framing member, and there's multiple cables there. After the foam is sprayed around the cables, heat transfers between the cables and eventually increases. This heat buildup can create conditions for a fire. Article 334.8 states, where more than 2 NM cables, also non-metallic cables, containing 2 or more current-carrying conductors are installed without maintaining a space between cables through the same opening in wood framing that is to be sealed with thermal insulation, caulk, or sealing foam, the allowable ampacity of each conductor shall be adjusted in accordance with the table 310.15b3a and the provisions of 310.15a2. This adjustment reduces the resistance. So using table 310.15b2a, determine the allowable ampacity of the conductor. Find the conducting material. So the conducting material will probably be copper. The rating of the insulation and the insulation type can be found in this column here. We know it's going to be a THHN, usually used in residential. THHN is rated for 90 degrees, just for the insulation. We also know that it's going to be a number 14 conductor. So if we take and go across the columns and meet the columns together, we can determine that the ampacity of a number 14 under normal conditions is 25 amps. Next, we need to determine the adjustment factors to be used to determine the allowed ampacity of each conductor. Our photo in the beginning appeared to have 8 non-metallic cables, each of those cables containing 2 current-carrying conductors, so that comes out to 8 cables times 2 conductors, and each one would be 16 conductors. Looking at table 310.15b3a, we would go down between 10 and 20 conductors, which would give us a derating value of 50%. Based on using a number 14 wire, we know that the ampacity is going to be 25 amps. We'll be using a reduction factor of 50% or 0.5. Thus, the allowable currents through the conductor will be 12.5 amps. The circuit cannot comply unless a 12.5 amp overcurrent breaker can be found, and to this date there are none made. However, as an option, the electrician can go with the number 12 wire, because the number 12 in table 31015B 3A would allow for 30 amps. If we reduce 30 amps by half, we come up with a 15 amps allowed through the conductor. A 15 amp conductor can be attached to a 15 amp overcurrent device and thus be in compliance. If we were putting a kitchen circuit in, which would have to be a 20 amp circuit, the number 10 would be required. What about calculating conductors that are within raceways? We use the same process to determine the base amps, which was going back to table 31015B2A. Find the conducting material, again, copper. Find the temperature rating and the type of insulation, THHN, in a 90-degree temperature. The conductor size, again, go with a 14. Go across the table, and where it intersects, we come up with the 25. If the piping is going to be put into an attic space, we need to account for ambient temperatures. Attic spaces generally get hot during the summertime. We'll assume for this example the temperature would be 124 degrees in the attic. So now we've got to go to table 31015B 2B to determine how the ambient temperature would affect the rating of the cable. If we go over to the far right column and trace down, I like to use Fahrenheit. If we're using ambient temperature Celsius, we can go to the far left column. We said it was 124 degrees in the attic. That would be between 123 and 131 degrees. Insulation of our wire was rated at 90 degrees. So again, if we take and follow down the columns and across where that intersects, that will tell us that our derating factor is going to be a 0.84. So if we go back to what our cable was rated at, number 14 is good for 25 amps. If we have more than 10 conductors in the conduit, we'll have to reduce it by half, so 0.5, 50%. And with the ambient temperature, we have to reduce it again by 80.84. The total reduction factor calculated would be 10.5. Unless you can find a 10 amp breaker, a larger conductor would be required. Thus you would be going to a size 12 wire. So that completes this lesson on derating cables. Thank you for watching.